Hello, students. Welcome to the practical class of Warehousing and Distribution Management. In this course, we'll learn about vehicle loading operations. How do you usually pack your suitcase when you travel? How do you pack more stuff in? Is your luggage neat and intact after unpacking at your destination? Have you ever been annoyed that your suitcase couldn't fit everything? Actually, truck loading is like packing a suitcase. If you do it right, it's safe, effortless, and you can fit more in. Today, we will reveal the scientific loading rules in logistics transportation to maximize the value of every inch of space. First, let's understand the unreasonable phenomenon of vehicle loading. Common unreasonable vehicle loading phenomena include overloading, underloading, low space utilization, improper mixed loading, wrong loading/unloading order, etc. What are the problems and hazards of overloading? Overloading is when the weight of the cargo exceeds the vehicle's rated load. It can easily cause traffic accidents, fines, or vehicle damage. Increased vehicle mass leads to a decrease in handling performance, especially in complex road conditions, such as turning or downhill. Vehicle stability is affected, increasing the risk of rollover. Overloading increases vehicle inertia, which weakens the braking effect and significantly extends the braking distance. In an emergency, it may not be possible to stop in time, causing serious accidents. Overloading puts extra burden on vehicle engine, transmission, suspension, and other parts, accelerating parts wear, which may lead to engine damage, tire blowout, and other failures. What are the problems and cost impacts of underloading? Underloading means that the vehicle space and load capacity are not fully utilized, resulting in uneven distribution of transportation costs and increasing unit transportation costs. Common underloading situations include insufficient vehicle space utilization. The weight of the goods does not reach the vehicle's rated load. Goods with small volume do not fully utilize the truck space. The main causes of underloading are insufficient supply of goods, failure to fully utilize vehicle volume, diverse cargo characteristics, difficult to effectively match, imperfect logistics planning, unreasonable loading plan, lack of standardized loading procedures. The adverse effects are mainly increased transportation costs, waste of transportation resources, increased safety hazards, and low environmental efficiency. Low vehicle space utilization, mainly manifested as loose placement of goods without fully utilizing the truck space. Unreasonable stacking of goods with gaps and unstable structures. Failure to use standardized packaging such as pallets, resulting in wasted space, which makes truck volume is seriously wasted, reducing transport efficiency and increasing empty driving rate, increasing transportation costs, and the goods are not firmly fixed, increasing the risk of damage during transportation. If goods are improperly mixed, improper mixing of goods with different properties may cause cargo contamination, damage, or even safety accidents, such as mixing chemicals with food could cause contamination, affecting food safety. Heavy items can crush fragile goods, leading to damage and increased losses. Incompatible goods mixed together can cause accidents, increasing transportation risks. Damage and contamination reduce the value of goods, increasing compensation costs. Incorrect loading/unloading order. Unloading then reloading causes repeated handling during unloading, increasing operational difficulty and complexity, easily leading to damage. It also increases operational difficulty and complexity, easily leading to damage to the goods. Frequent handling and reloading extend loading/unloading times, affecting distribution efficiency. Extended loading/unloading times reduce vehicle turnover, reducing overall distribution efficiency. So, what principles should be followed for proper vehicle loading? Next, we will learn these 8 loading principles in detail. The first is the principle of matching light and heavy items. Heavy goods should be placed at the bottom of the carriage to ensure vehicle stability. Light goods should be placed on top, making full use of space. Heavy goods close to the central axis of the carriage ensure balance. which reduces the risk of rollovers and improves driving efficiency. Therefore, load heavy goods first, then load light goods to ensure the vehicle's center of gravity is balanced and stable. The loading effect is shown in the figure. Second, the principle of matching large and small sizes. Large goods should be loaded first, and small goods later to fill the gaps, making reasonable use of geometric features. Improve loading space utilization. In daily operations, large goods are usually located at the bottom or center of the carriage, and small goods can be placed between or on top of large goods. Pairing goods with complementary shapes can reduce gaps. The loading effect is shown in the figure. Third, the principle of matching cargo properties, according to the characteristics of the goods, such as fragility, danger, odor, etc. Reasonably partition and place, to prevent cross-contamination and damage, and ensure transportation safety. Unreasonable loading situations include mixing food and chemicals can easily cause contamination, affecting food safety. Mixing fragile items with heavy goods. Heavy objects may crush fragile items, causing damage. Mixing goods with different odors, cross-contamination. Mixing dangerous goods with ordinary goods increases transportation risks, endangering safety. Therefore, different color labels can be used to distinguish cargo properties. At the same time, establish a standardized loading process. Regularly check the loading results and ensure safety. In addition to this, there are several other loading principles. Concentrate goods to the same location for loading. Suitable goods arriving at the same location should be loaded together as much as possible, reducing the number of times they need to be reloaded midway, and improving loading and unloading efficiency. Reasonable stacking levels. Determine reasonable stacking levels and methods to ensure the goods are stable and safe. Avoid instability and safety hazards caused by overstacking. Strictly control the maximum load capacity. Loading is not allowed to exceed the maximum load capacity allowed by the vehicle. Ensure the vehicle operates safely, avoiding fines or accidents from overloading. Distribute weight evenly, ensuring cargo weight is evenly distributed. Avoid front heavy, rear light, or side imbalances. Maintain vehicle handling and safety. Prevent collisions and contamination between goods. Prevent collisions and contamination of cargo. Arrange loading order and position of different goods properly, avoiding mixing fragile items with heavy goods. So, are there any methods to help us with effective and reasonable loading? Next, let's learn about the stowage factor method. In vehicle loading, goods with a high stowage factor generally, like hardware, often leave a lot of volume space when reaching the vehicle's load capacity. Goods with a small volume, such as cotton yarn clothing, do not reach the maximum load capacity even when the compartment is full. Both situations result in a severe waste of transportation capacity. Therefore, when there are fewer types of goods, and the characteristics of the goods are obvious, it is more effective to use the stowage factor method for loading. Stowage factor is generally the weight per cubic meter and the weight of an object per unit volume used in engineering. Therefore, the stowage factor method comprehensively considers both weight and volume factors. By constructing a system of equations to solve for the different loading quantities and volumes of light and heavy goods, to arrive at the optimal solution. What is the calculation principle of the stowage factor method? Suppose there are two types of goods that need to be delivered. A bulk weight of cargo is Ra kg per cubic meter. The volume of a single piece is Va cubic meters. B bulk weight of cargo is Rb kg per cubic meter. The volume of a single piece is Vb cubic meters. The rated load capacity of the vehicle is G tons. The maximum volume of the vehicle is V cubic meters. Considering that the combination of sizes of goods A and B cannot perfectly fill the vehicle's internal space, and there may be unusable space after loading, the effective volume of the vehicle is set to 90% of V. Now, calculate the loading plan. Assuming that the number of goods A loaded is X or the number of goods B loaded is Y, under the premise of being fully loaded and full of capacity, a system of equations can be obtained. X times VA plus Y times VB is less than or equal to V times 90%. X times RA times VA plus Y times RB times VB is less than or equal to G. To solve this equation set, the values of X and Y obtained are the quantities of A and B goods loaded respectively. To summarize, the calculation steps of the stowage factor method are: 1. Determine the constraints. The total weight of the goods does not exceed the vehicle's rated load capacity. The total volume of the goods does not exceed the vehicle's effective volume. Consider that the vehicle's effective volume is usually 90% of the theoretical volume. 2. Establish the system of equations. 3. Solve the system of equations. Solve for the optimal values of X and Y using linear programming methods. 4. Verify and optimize. Verify whether the calculation results meet the actual business needs. Consider how the goods are stacked and the stability requirements. Optimize the loading plan based on the calculation results. Next, we'll use a case study to reinforce our understanding of loading methods. Wanchitong Distribution Center needs to load two types of goods: canned goods and bread. The bulk density of the canned goods is 1,200 kilograms per cubic meter. The bulk density of the bread is 600 kilograms per cubic meter. The planned vehicle has a carrying capacity of 11 tons. The volume of the carriage is 15 cubic meters. Please design a loading plan so that the vehicle's load, weight and volume are fully utilized. Then let's solve the vehicle stowage problem of the Wanchitong Distribution Center according to the implementation steps of the bulk density method. First, determine the constraints. Maximum load capacity, 11 tons. Maximum volume, 15 cubic meters. Let the load weight of canned goods be X kilograms. The load weight of bread is Y kilograms. Establish a system of equations. X plus Y is less than or equal to 11,000. X divided by 1,200 plus Y divided by 600 is less than or equal to 15. Solving the system of equations gives X equals 4,000 kilograms, Y equals 7,000 kilograms. Scientific loading is a win-win rule for safety and efficiency. Students, every reasonable load you make is protecting lives, reducing the burden on the earth. Now, are you ready to optimize your logistics luggage? Next, we'll go through a set of small questions to consolidate the knowledge points we learned today. Question 1. Which of the following loading arrangements is incorrect? Question 2. Which of the following is more suitable for loading by cargo category? Question 3. Which of the following is more suitable for loading by customer? Question 4. Which of the following loading arrangements is incorrect?